Okay, so now wrapping up the discussion about equation 8, we've already shown in this playlist, which by the way, the link to this playlist will be provided in the description of this video, as well as a link to this paper. Okay, so we've already shown this first piece here, the second derivative of the log likelihood with respect to beta I and beta j. And then we also showed this piece here. Remember this z, this is a typo. This should be the second derivative of the log likelihood. So it should be an L. With respect to y, we showed that using product and chain rule, you can get this piece here. So now the focus of this video is these next two steps right here. They do depend on equations that we've already discussed previously in this playlist. Just as a reminder, so we'll be needing the first derivative of the log likelihood, which is equation 3, the second derivative of the log likelihood, which is equation 5, and this b definition here in equation 6. Okay, so I've written those all here on my blackboard, and yeah, actually these last two steps aren't too bad. I feel like the first two parts of talking about equation 8 are a little more challenging. Right now we're just kind of plugging and chugging and seeing how things change. So this piece here, let's go ahead and plug in equation 5, which we've already discussed, and equation 3 here. Right? You can go back earlier in the playlist if you want to see why these two are true. Okay, and then I think I'll use the chain rule here and kind of expand this piece as well. Okay, so let's go ahead and do that. So I'm going to plug in equation 5, so I'll have negative alpha of phi times v, and then d theta, d mu, dy. Okay, so you see I've just used chain rule, and then basically the d mu's, they cancel, so I'm left with what's there, so I haven't actually done anything other than use chain rule. Okay, and then I'm going to plug in equation 3 here. So d phi z minus mu, and then I leave this last piece out back, leave that guy alone. Okay, so let's see, I can maybe pull out this piece, and I can distribute that squared. So let's go ahead and do that. So I'm going to pull out alpha of phi. I'll still have that negative v. Don't forget the negative sign. And let's go ahead and square both pieces of that product. Okay. All right. Now what? Now I can actually, let me pause here for a second, because I do believe that this is that line that's right before the last step of equation 8. So you can double check and see, okay, yeah, we're on the right track. So okay, so last thing I need to do is maybe I can simplify this piece right here. Or actually I can, simplify both of this. How can I do that? Well, in equation 6, I have v equals d mu d theta. Okay, I can use an inverse property for derivative and say that this is, that 1 over v is d theta d mu. All right. And I can plug this in for d theta d mu. So let's do that. So I have negative v, and then 1 over v squared. So you see I've plugged in for d theta d mu, I plugged in 1 over v. Okay? D mu dy squared. And I'm not doing anything else in the back here. Okay, and I notice I have some cancellation. This v cancels with one of the v's in the denominator. And I am left with equation 8. Okay, so I still have that negative. I have d mu dy squared over v, okay, because I still have a v in the denominator, and then plus z minus mu okay, and that is what equation 8 says.